Hi everyone. I was checking the video that I told you that we created last year regarding the critical path calculation and the second way how we can calculate some information about time and develop schedule. And I was checking, and that video, I think it's too long. It's taking too long, more than 28 minutes. And I make a decision today to redo the same content. And now I'm trying to do it in less than 15, 16 minutes. So just to provide an overview of the project schedule management, remember that in this type of knowledge area, we have 6 processes. We have plan schedule management, define activities, sequence activities, estimate activity duration, develop schedule, and control schedule. 1, 2, 3, 4, 5, 6. So the critical path methodology is just about understanding that this is a tool for this process, develop schedule, right? And when we see the definition of develop schedule, in summary, it's just defining the start and finish dates for each activity, right? So if you see the example that I gave you last week, this is not one of the questions that we can answer doing this type of exercises. So this example is only valid if you need to know what is the critical path and what is the project duration. However, in this example, I didn't explain how to define the start and the finish of each activity. Another information that this type of exercise does not provide is the total float for each activity. So I'm very happy because last week, I think we understood very clear that this type of methodology, it's valid and we can use it to determine 2 things, the critical path and the project duration. However, if you see in the exam a question that is asking for the total float for one activity, a specific activity, or what is the start date of any activity, you don't know how to do it. So this methodology, it's called quick method. That's the one that I explained. So just to provide an overview, as you remember, the first thing was to determine the possible paths. In this case, we identified 3 different paths. We calculate the duration, and the critical path was the longest path into the network, and we did it. So we found that ABDF, the duration was 11 days, the number 2, 16 days, and the number 3, 15 days. So by definition, the critical path is the longest path into the network, which is ACEF. The total project duration is 15 days. So we are good to go in this case. So critical path, by definition, is the longest path through the network. We know that is very clear. And that is the rest of the exercise that we did. And we also determined that the project duration was 16 days. So let me go back to make sure. 16, yeah. The critical path is the longest path. Yeah, 16 days. And it's ABEF. All right, let me just go. Oh, I said this one, so this is not the one. Sorry, it's the longest path, which is ABEF. And just making sure that I don't want to confuse you. Anyways, we know that. So the purpose for this video is not to explain one more time the same exercise that we did, but I wanted to just provide an overview because I want you to see the difference between this type of exercise and the other one that I'm going to present right now. Let me just stop sharing my screen and let me go back to the PowerPoint presentation and go directly to the other example that I want to present. So I'm navigating into my document in PowerPoint so I can start sharing the specific screen that I want to show you. Okay, it's done. Okay, I think you can see my screen now. Yes, I'm sharing my screen. Remember the previous methodology was the quick method or eyeball. However, this one, the name, it's another name. The name changes. This is a no quick. So what is the difference between the quick and no quick is that this one, we need to determine or answer 2 additional questions that we didn't do with the previous methodology. So in order for us to determine the total float for each activity and the early start and the late start of each activity, we need to follow another process. Number 1, we need to calculate the forward pass, which is the early schedule. Number 2, we need to determine the backward pass, which is the late schedule. Number 3, now we can calculate the total float using a formula. And number 4, we can now identify the critical path based on different information. So if you see each activity contains the early start, early finish, late start, late finish. I'm going to explain later. So the forward pass is, is when you determine the early finish and the early start for each activity. So the early start, it's the initial date. However, the early finish, it's early start plus the duration that is here. So what are the formulas? Here to determine the early start, early finish, late start, late finish, using these 2 formulas. This is for the forward pass and this is the backward pass. So let's get started this exercise. So when it's the early, what is the earliest start of activity A? The earliest start of activity A is 0. So what is the early finish? 0 plus 3 is 3. What is the earliest start of activity B? Is 3. You cannot start before. You need to wait until the activity A is finished, right? So the same thing, it's for activity C. What is the earliest start? It's also 3. So this is let me just put here, early start, early finish, late start, late finish. So what is the early finish of activity B? Is 3 plus 5, which is 8. What is the early finish of activity C? 3 plus 4, it's 7. And so on. But in this case, in activity E, we have 2 options here. So what is the early start here? So we need to make a decision and we need to select the largest value, the biggest one, which is 8, not 7, but 8. So the earliest start for activity E is 8, and the early finish is 8 plus 6, which is 14. The earliest start for activity D, it's 8, and the early finish is 9. 8 plus 1, 9. In this case, what is the early start of activity F? Anyone? So it's the biggest number, it's the biggest one between 9 and 14, which is 14. So what is the early finish? 14 plus 2, 16. That was, we finished the forward pass, right? Forward pass. This is the step number 1. Let's say, do I need to calculate that in the exam? No, but you need to understand the concept. So this is the forward pass, which is the early schedule for this project. It's the same thing that I just calculated right now. You see, 3 plus 5, 8, 7, 9. This is exactly the numbers that I just did it before, the previous slide. Now that we have the early schedule, it's time to move forward with the next step. So forward pass is done. Boom. Now we need to calculate the backward pass using the formulas. So the backward pass, it's the opposite. It's from the right side of the schedule, the network, to the left side of the network, schedule network diagram. So the late finish for activity F is 16 plus 2 minus 2. Now it's different, it's the opposite. 16 minus 2, it's 14. Let me go back to the formula so you can see it here. You see, this is subtracting. This is plus, this is minus. Okay, let me continue. So backward pass is 16 minus 2, 14, right? So what is the late finish for activity E? This one is this same 14, and here's 14. So what is the late start of activity D? It's 14 minus 1 is 13. And what is the late start of activity E? This number? 14 minus 6 is 8. Right? So in this case, for activity C, the late finish of activity C is 8. Just copy and paste it. And the late start of activity C is 8 minus 4, which is 4. So for the activity B, we have two options, or 8 or 13. In this case, we need to take the lowest value, which is 8 here. So 8 minus 5 is 3. And for the activity 3, we have two options. What is the late finish of activity 3? Between 3 and 4, we need to take the minimum value, which is 3. 3 minus 3 is 0. So now we just calculated the backward pass, which is the late schedule. And with that, you see, it's the same numbers that I was doing manually. We just finished with the backward pass. Now it's time to move to the next step, which is calculate the total float. So this is the information that we didn't do before with the example that I gave you last week. So the total float is equal late finish minus early finish. That is the formula that we need to apply. So in this case, what is the total float of activity A? Total float of activity A, it's late finish, which is this one, 3 minus early finish, which is 3. So 3 minus 3 is 0. So the total float of activity E is 0. Is that clear? Late finish minus early finish. This one and minus this one. So we do the same for each activity. Total float of activity B, total flow of activity D, total float of activity C, and total float for activity E. Total float for activity F. So in this case, it's 8 minus 8, 0. Activity D, 14 minus 9, I think it's 5. Yeah. For activity E, it's 0. For activity C, it's 1. For activity F, it's 0. So another methodologies that we can use to identify the critical path is just understanding that the activities with total float equals 0, those are the activities that are part of the critical path. See, total float 0. Let me erase my numbers so you can see that those are the same values that I was calculating. So total float of activities is 1. Activity D is 5, and I said that before, 0 and 0. So if I tell you that the total float, those activities that have a total float equals 0 are the critical path, now we can identify the total float of this project, or the critical path better. So now it's time to identify the critical path. How can I identify the critical path? It's because the critical path, it's the one that it's formed by the activities with the total float equal 0. So, which are A, B, E, and F. So it's A, B, E, and F. That is the critical path. So now that I just developed this type of exercise, if you see a question in the exam, what is the earliest start of activity D? Now you know that it's 8. You see? That was a question that we're not able to answer using the previous example that I gave you. So what is the summary of this exercise? Is that critical path is the longest path through the network, the path with the least total float for the exam, and also is the shortest time that the project can be completed. Activities in the critical path almost always have a 0 float. You said, why almost? Yes, because if you see some examples, you can find in the exam or in any book that the activities in the critical path can be the less value. So it's almost always 0, but it's the one who has the minimum amount of the total float. That's the answer for the exam. So let me just make sure we understand what is the critical path. It's A, B, E, F, and the project duration is 16 days. So this is the objective of this video. It's to show you another methodology to develop the schedule using the no quick methodology. This is the end of the example. Please let me know if you have any question, and remember that for the exam, you don't need to calculate every single number, but you need to understand the concept and also understand the formula and understand how to apply which one in what cases. So have a wonderful weekend, and I'll see you tomorrow morning in the class. Good night.